Greetings, guys. Here is our first lesson. The other lesson I did the bow ties. That was to help you out through this whole section here. So this is section 5.4, lesson 1. These are the problems right here that I think you should be able to do easily after this lesson. But if you need more practice, do some of the evens till you're comfortable with everything. Here's the answer key for 1 through 18. I'm going to scroll down. Here's the answer key for 19 to 25 or 26. But here's what we're up against. On page 216, you're going to see some new formulas. They're in the brown boxes, and just like with cosine, we have sine A plus B and sine A minus B. Then we also have a tangent one, but I'm going to do one at a time. So first we're going to do sine A plus B. Now here's the thing. I want you to really take this to heart. During a regular school year, I do not allow you to have formula sheets or anything like that because I know what's coming in calculus. You have to have this stuff in your head. But I can't prevent you from looking at a formula sheet when you're doing this at home. But it is a word to the wise, so let me show you how I keep this in my head. I already told you when it comes to cosine, when it comes to a cosine problem, and they give me some cosine A plus B, to help myself remember it, I call it couscous. You know what? Use what works for you. So I call it couscous. And then I also know when it's a cosine, it's a plus. That means in the formula, it's a minus. You use the opposite. Then it's sine A, sine B. That's how I keep that one memorized. I call it couscous. I also realize that the signs are opposite. So, here's how I remember the sign problems. I like to use a little accent. And I will explain this in a minute. But this is the formula that you'll see in the brown box. If it's sine of angle A plus B in parentheses like that, it's sine A cosine B. Notice that the plus sign is there in the formula. So sine is nice and easy to remember the sign. If it's a sine A plus B, it's a plus in the middle. Just like it is down here, it's sine A cosine B. It's a minus in the middle. And then we go cosine A, sine B. Here's how I remember this. I think of, if somebody asked me, how many cosines do you have? Cinco cosine. Whoop, I wrote that thing wrong. I just noticed that. Duh. Dang it. Whoop. Whoop. I got to get my pen. There it is. Whoop. See, I fixed a mistake already. Cinco cosine. That's how many cousins I have. Cinco cosine. Okay, if it sticks in your head because of that stupid thing I say, good. I want it to stick in your head. That's how I remember it. So, sine A cosine B plus cosine A sine B, etc. They're very similar to each other. Now, the good thing is we just went through a lot of stuff in section 5.3, so you already know how to do this stuff. So I don't have to really spend a lot of time doing it. You just have to use the formula correctly. And I broke it down into a couple chunks this week. But you know what? We're down to the nitty-gritty. We are just going to be working through problems till we get to the end, and then we're going to take the final. So this week, next week, all of it is work. Now, the final will be, I don't have it written down. I think it's June 9th, which is a Tuesday, because school's out on a Thursday. And I wanted to give you a couple days in case something goes down in your house, you're no internet or something. I wanted to build in a cushion there So anyway, I do believe it is June 9th, a Tuesday, that we take our final at 12:30, because that's our reserved time slot. Nobody can take that slot. So let's do this here. We're going to look at a couple examples, and I'm going to do sine of 75 degrees. If I do sine of 75 degrees, I could rewrite that using my buddies that I know so well, 45 and 30. And then that comes to reference triangle stuff. But if you have your bow ties, like I showed you in the other lesson, you have your bow ties there, you could just use the bow tie stuff. And how's it going to look, though? It's going to look like this. Just like it did with cosine. Sine 45, cosine 30. It's a plus, so it stays a plus. Sin cos, cosine. I know it's goofy, but it sticks in my head. So now all I have to do is I have to think, well, what does my, 45 reference triangle look like, etc. But if I got my bow tied down, bam, I'm going to say that's 1, 1, that's rad 2. That's for my 45. And if I'm thinking about my 30, I already have a bow tie I could look at. That's my 30. That's a 1, rad 3, and a 2. And then I just have to fill in the blanks for it. I say, what is the sine of 45? Well, it's opposite over hypotenuse. Times, what's the cosine of 30? Rad 3 over 2. Plus, then I go, what's the cosine of 45? 1 over rad 2. Times, what is the sine of 30? That's 1/2. And let's clean this up. If I multiply the first two fractions, I get 1 times rad 3 on the top, that's rad 3, over 2 rad 2. Plus, on the top, it's a 1 over 2 rad 2. They already have common denominators, so I'm just going to rewrite it as rad 3 plus 1 over 2 rads of 2. I'm going to take the entire top and the bottom, and I'm going to multiply it by rad 2 to get that to rationalize. So in the bottom part, I've got a 4. Because we just did the last section, we can speed up a little bit. Rad 2 times rad 2 is 2. 2 times 2 is 4. And on the top, I would drop it like it's hot, and I would get rad 6 plus rad 2, the whole thing, over 4. And just a reminder, this is called exact values. That's what they want from me. I need to give them exact values. Now, sometimes they'll give me degree measurements. Sometimes they'll give me radian measurements. So let's try this one. Let's do the sine of 7 pi twelfths. Now, this lesson, I can only go so far. I try to keep my lessons within a reasonable time frame. But this is where we have options. We do have options. I could convert 7 pi twelfths into degrees if that makes my brain happier. But one skill you're going to find, it's actually pretty quick, has to do with our bow tie concept. Think of the bow ties and even the quadrantals. Let me scroll down and I'm going to show you what I mean. If I have a quadrantal, it's a multiple of pi halves. If I had a 60-degree angle, it's a pi third. If I had a 45, it's a pi fourth. If I had a 30, it's a pi sixth. The common denominator for all those denominators there would be twelfths. This guy right here could be written as 6 pi twelfths. This guy could be written as 4 pi twelfths, 3 pi twelfths. This guy could be 2 pi twelfths. So what I'm trying to say is, it looks like if I took 4 of them and 3 of them, put them together, I'd have 7 of them. So I could expand this thing out using my bow tie concept. Now I'm going to write out the whole way just so I don't lose anybody, but I'd jump right over this step. I would say, okay, I could write this as sine 4 pi twelfths cosine 3 pi twelfths. And I'm adding to get that, so I'd use a plus in the formula. Then I'd say cosine 4 pi twelfths sine 3 pi twelfths. But here's the thing. I don't usually write it out that way. I don't. Because I use this concept. Here, I'm going to get a different color. I use this concept that I know they all can be written as twelfths, but I do this. I say, oh, that would just be sine of, what is, it's pi over 3. Then I have my bow tie. Cosine, what is that? It's pi over 4. What is it? It's now I've already got it. The rhythm is already there. So once again, all I'm doing is I'm using reference triangle information. I already have my pi over 4 from the other problem. That was my 45. I can think of it as a pi over 4. But if I have my bow tie ready, it's 1, 1, rad 2. And for a pi thirds angle, pi thirds reference angle, I could just look at my bow tie and say, oh, that's 1 rad 3, 2. And once again, what am I doing when I use these sum and difference formulas? I'm just substituting in the actual values. So I say, what is the sine of pi over 3? Well, that's rad 3 over 2 times, what is the cosine of pi over 4? Well, it's 1 over rad 2 plus, and then I just keep going. 1/2 times, and then 1 over rad 2. And just like with the cosine formula, you start noticing these values that appear a lot. On the top, I have rad 3 over 2 rad 2 plus 1 over 2 rad 2. Hey, this looks like something I've seen before. I'm going to put it over one denominator. I'm going to multiply whole top, whole bottom by rad 2. And if I drop it like it's hot on the top, I'm going to get a rad 6 plus a rad 2 over 4, which, hey, wasn't that my last answer? You notice a lot of repeating values in trigonometry. It's okay to find repeating values. But you know what? Did I do that? Yeah. Pi over 3? Yeah. Okay, I just wanted to double check myself here. So, here we go. Let's talk about how we would use the tangent formula. So the tangent formula is, oh shoot, what is it? I think it's page 216, brown box. So we have tangent A plus B, and we have tangent A minus B. I don't know why I capitalized the T on tangent. I normally don't. It's not going to affect things. But I should have left myself a little more room, because you'll see in a second here. I'm going to get rid of all this stuff. God, I'm getting better at this thing, guys. Here we go. If it's tangent A plus B, it starts out with tangent A plus tangent B all over 1 minus tanatanba. That's what I call it, tanatanba. That is the sum formula. And the nice thing about the difference formula, here I'm not going to capitalize it this time. I don't know why I capitalized it. A minus B. The sign that you start with dictates what sign you use in the numerator. And then the sign in the denominator is the opposite of that, but it all ends up with tanatanba. Tanatanba. There's my formulas. Like I said, I think they're on page 216. Yeah, what the heck, it must be. And we're going to do these guys. So let's do, since we just used tangent of what, 7 pi twelfths? Yeah, what the heck, let's do it again, because I already have those reference triangles drawn. That'll save us a little time. That would be the same thing as tangent. Now, what did I use? What was it? Pi thirds plus pi fourths? I believe that's what it was. Let me just double check. Saving myself a little trouble here. Yep, 4 pi twelfths and 3 pi twelfths. That would be pi thirds and pi fourths. So, we already had our reference triangles, but you know what? Just in case. Pi fourths. I already have my bow tie. Wow, pi thirds. That was a pretty aggressive x-axis. And that's going to be 1 rad 3 and 2. So let's see how this thing works out for me. And you're going to notice a little bit of something from your past coming up here. So I do tangent A so tangent of my A value, I'm using my pi over 3 reference, plus tangent of my pi over 4, 1 minus tangent A times tangent B. Let's go grab our numbers. So what do they want me to use for tangent of pi thirds? Opposite over adjacent, they want rad 3. What did they want me to use for the tangent of pi fourths? Well, I lucked out there. That's 1 over 1, opposite over adjacent. Down below, I got 1 minus, so I'm going to just say, what is that? Rad 3 times 1, which is rad 3. And welcome back to something we did in the first, 2 units of school. I have to get rid of the radical in the bottom, so I multiply by the conjugate. That is what we did when we ran into that situation. Remember, this is a big old foil-orama. So in the bottom, if I foil this, I get 1 times 1, that's 1. If I did negative rad 3 times regular rad 3, I would get negative rad 9, but I don't want to call it negative rad 9. Heck, I'm going to get rid of that. I would call it negative 3. What does that mean? In the bottom, I've got 1 minus 3, negative 2. Now, why didn't I do these 2 parts? Because they're going to cancel. That's why we use a conjugate. But in the top, in the numerator here, we got a little bit more work to do. So rad 3 times 1, I get rad 3. Rad 3 times itself, I get regular 3. 1 times 1, I get a 1. Here I get another rad 3. So I end up with 3 plus 1, that's 4. Rad 3 plus rad 3 is 2 of them. But that is not the answer they have in the book. Why? Number 1, I told you guys this long ago. Don't leave your negatives in the bottom, run them through the top. Also, do you see the triple, the trifecta, the threep? You see it? 2 goes into that, 2 goes into that, 2 goes into that. Run the negative through the top. The answer you're going to see in the back of the book is negative 2 minus rad 3. That would be the answer that you would arrive at if you did that question correctly. So, sine A plus B, sine A minus B. Same rhythm very much as the cosine. Tangent, however, will sometimes throw a little wrench at us because you get these weird numbers. And that's okay. It's okay to get a weird number from something. While I'm here, I'm going to do one more, but I want you to see how they might do this to us using tangent. Let me get back to a black pen. And they might do something like this. They might say tangent of 40 plus tangent of 160. Wait a minute. Sorry. Make that a minus. Make this work out. Making them up on the fly, guys. So I'd say tangent of 40 minus tangent of 60 over 1 plus tangent 40 times tangent 160. Now, I want you to just look at that for a second and say, what are they trying to make me do? It looks like they gave me the expanded version of this formula. Did they give me the tangent A plus B version or the tangent A minus B version? Well, let's look at the numerator. What sign did they give me in my problem? They gave me a minus. So what they're trying to say here is you can either go forwards or backwards. If they give you this type of look right here, you can rewrite it as, well, this is just the tangent of 40 degrees, take away 160 degrees. Well, what does that do for me? Well, that means you're looking at the tangent of a negative 120 degree angle. What is the tangent of a negative 120 degree angle? Well, isn't that thing a multiple of 60 degrees? I have a bow tie that if I drew the whole bow tie out, I would still end up with, chink, this little chunk right here. If that's a negative 120 degree angle, that means I got a 60 right there, which means I'm in quadrant 3, which means, hey, opposite that 60, that's a rad 3, but not so fast. It's a negative rad 3. That would make this guy a negative 1. That would make this guy a 2. And I use that reference angle and I say, I know what the tangent of negative 120 is. It's negative rad 3 over negative 1, but I just call that rad 3. So remember, in mathematics, sometimes we're factoring, sometimes we're foiling. Those are opposite operations. Sometimes we're adding, sometimes we're subtracting. Those are opposite operations. So sometimes they give me something like this, and I have to expand it and evaluate it. Sometimes they give me what the expansion would look like. This part right here. Sometimes they give me what the expansion would look like, and I take it and I work it backwards to fill in the blanks, and then guess what? I told you to watch the intro lesson because you're going to be drawing so many reference triangles to do this. You might as well have your bow ties sitting right in front of you for all your pi over 6, pi over 4, pi over 3, pi over 2 is quadrantal, so you use the graph to help you do that. So if you look at the problems, I'm trying to find the page here. Page 220, like I said at the very beginning of this assignment, or this lesson, page 220, 221. I want you guys to try and do 1 to 25 odd. The answer key is already at the very top of this lesson. You can just rewind the video. But just for kicks, one more time here. If they gave me something like tangent of negative 5 pi twelfths, and they said, can you find the answer for that? Well, I would think to myself, how could I get a negative 5 pi 12ths. Let's scroll back up just real quick. And I look at this and I go, 5 pi 12ths. Hey, if I had a negative 3 pi 12ths and a negative 2 pi 12ths, I could do it that way. But with these formulas, check it out, I could do the tangent of, let's say, negative 2 pi 12ths, what the heck, minus 3 pi 12ths. Then what am I really doing here? I'm going to have a negative angle. That's a negative pi 6th. I'm going to have a positive angle, but I'm going to take it away if I treat it that way. That would be pi over 4. So my hint to you is this. If you're going to write it out like that, be careful. This angle is going to put you in which quadrant? Quadrant 4. If you do negative pi 6th, you're going to end up with this guy right here. This guy would be, opposite that would be the negative 1. Here would be a rad 3. This would be a 2 because that's the same as a negative 30-degree angle. This guy right, what did I do? This guy right here, that guy's going to generate a quadrant 1 angle. This dude would be your pi 4th, 1, 1, rad 2. You don't ever have to draw a bunch of reference triangles if you got your bow tie sheet sitting right in front of you. And eventually, you're just as fast as I am at it, and you don't even worry about it. You just go, oh, I could do this. What the heck? What would this one look like? It would look like tangent of negative pi 6ths minus tangent of positive pi 4ths, because I chose to use the subtract formula. On the bottom, what do I have? 1 plus tangent negative pi 6ths times the tangent of pi 4ths. So let's, what the heck, let's finish this one off. If I did take the tangent of negative pi 6. Here's my negative pi 6 reference over here. Here's my pi 4th reference over here. If I did do the tangent of negative pi 6, I would get opposite over adjacent minus, now tangent of pi 4ths, I would do opposite over adjacent. On the bottom, I have 1 plus, well, tangent of negative pi 6 again. It's going to be a negative 1 over rad 3 times the other guy, that's a 1. But I wanted to show you guys this. I made it look like fractions. But here, I'm going to do a positive negative thing. Because sometimes we get a complex rational when we use the tangent formula. Complex rational when we use the tangent formula. Oh my gosh. Now this is what I taught you and what I want you guys to embrace. You take the whole top of this thing and the whole bottom of this thing and you multiply by the LCM, which is rad 3. And when you do that, then you have no more double fraction. I will end up, first part, they're going to cancel. I get a negative 1 minus rad 3 times 1 is rad 3. On the bottom, if I multiply this in, what am I going to get? Rad 3 minus, they're going to cancel. I'd get a 1. And then I'm right back to conjugate town. I'm right back to where I was in conjugate town. I have negative 1 minus rad 3. Over rad 3 minus 1. I want to multiply top and bottom by the conjugate. A lot of work. Here we go. Rad 3 times rad 3 is 3. I don't have to worry about checking the middles. They're going to cancel each other out, so I just go firsts and lasts. That's minus 1. What's in the bottom? That's a 2. Not a negative 2. That's a regular 2. In the top, let's clean up that numerator, see what we get here. If I FOIL this out, that's negative rad 3. Then I'd get a negative 1. I get negative rad 3 times regular rad 3 is the same as negative regular 3. And then the last part here is negative rad 3. So let's put it all together. Negative 1 minus 3 more is negative 4. Negative rad 3 minus 1 more is minus 2 rads of 3. And then look for the beauty. Bam, cha-bam. That looks like my answer is negative 2 minus rad 3. That's what it looks like. Hey, I had to do a lot of cleanup to get that far, but I got there. That's why I said do the odd ones, which, by the way, right there, I'm just going to tell you, I stole this from the book. This is problem number 17. So let's check my answer. I got negative 2 minus rad 3, and we go all the way back up to the top. Number 17, where is it? Negative 2 minus rad 3. There it is. Oh-ho.